I am Anil Kumar. Let me thank all my viewers and subscribers for watching my videos and posting excellent questions. Here is a question which is from GCSE based on inequalities. Here's a very interesting problem which we'll see how to solve using graph. The question is, Hassan is making some toys to sell at a school fair. Hassan takes 40 minutes to make toy A and 20 minutes to make toy B. He has total of 20 hours to make toys. He makes X of toy A and Y of toy B. He needs to make at least 6 of toy A and toy B should be at least twice toy A. So this sentence is, he needs to make at least 6 of toy A and toy B should be at least twice the toy A. Define the constraints. This is the question. Define the constraints. Represent constraints on the grid. Find the greatest amount of money he could get by selling toy A for $3 and toy B for $2. So basically what I've done here is that I've seen the question which has been provided to me, and I've rewritten this question so that we could answer clearly, right? And that's the graph on which we need to plot the straight lines, linear inequalities to solve and get the answer. That's the whole idea. Now let us understand how to solve such questions. So it says Hassan is making some toys to sell at school fair. Here they have also mentioned that take X, he makes X of toy A and Y of toy B, right? So these are the two variables which we are going to take. Hassan takes 40 minutes to make toy A. So from here we can find the rate for making toy A. 40 minutes means what? 40 minutes means if I divide by 60, I get in hours, right? So 60 minutes is actually 1 hour, correct? So if I do that, I get the time in hours for one toy, right? So this gives me cancelling zeros and then simplifying, we get 2 over 3, right? So we get for one toy, the rate is, let's write like this, 2 over 3 hours per toy A. Is that clear? Now 20 minutes to make toy B. So that means, let's use another ink. 20 minutes means again we'll do 20 divided by 60. So that gives at the rate of 1/3 of an hour. In 1/3 of an hour, he could make toy B. Right. In 2/3 of an hour, he makes toy A. Now he makes X of toy A and Y of toy B. So that how much time will he take? For X toys, time will be X times the time taken for one toy A, right? So it becomes 2 over 3 X plus Y toys of toy B. So the hours will be 1 over 3 of Y. So he makes X of toy A and Y of toy B. So that is the total time. So this is the total time to make A and B toys, right? For each toy, he is taking 2/3 of an hour and 1/3 of an hour respectively. So X of A and Y of B will give us 2/3 of X plus 1/3 of Y in hours, right? Then it says he needs to make at least 6 of toy A. So at least 6 of toy A means that X is number of toys A being made. It has to be greater than or equal to 6. That is at least 6 of toy A, and toy B should be at least twice toy A. Toy B's Y should be at least twice toy A means 2x. Is that clear to you? So as we read, we form our equations. Correct? Now let us see, define the constraints. Now here, We are also given that Hassan takes 40 minutes to make toy A and 20 minutes to make toy B. He has total of 20 hours to make toys. So let's underline this particular statement. He has total of 20 hours to make toys. And in hours, time taken is all this. So this time should be less than or equal to 20 hours. Do you get the idea? So one of the constraints which we get here is from here. We get that this sum, which is, let me write here the space, 2/3 of x plus 1/3 of y should be less than equal to 20 hours. This is time in hours, right? This is total time in hours. So that is total of 20 hours to make toys. So that is the constraint which we get. Now to simplify this, what we could do is we could times this equation by 2 to get rid of fractions, correct? So the whole thing will times it by 2. So if you do that, you get your constraint, which is, rather 3 is the denominator, I'm sorry, times it with 3. 3 is the denominator, right? So when you times it with 3, you get 2x plus y should be less than equal to 60. So that is what you get when you times this equation by 3. So that becomes one of your constraints. The other two I've already mentioned, right? So this is, let me now write this as 1, this is 2, and this one is a third constraint for us. Correct? So these are the 3 constraints. We need to represent these constraints on the grid. So I'll do it on the next page. We'll just we know all these 3 constraints. And then find the largest amount of money he could get by selling toy A for $3 and toy B for $2. So that is the final part, correct? So now let's look into sketching the graph for these inequalities, and then from that graph we'll figure out what should be the greatest amount of money he could get, right? And the rates are given to us. Toy A is for $3 and toy B is for $2. Now to give you in short, let's look into this also here. So basically what we're trying to do is we'll have a graph. On this graph, we'll sketch these 3 lines, right? X greater than 6 means, I'm not writing any values, greater than 6 means on this side, right? All positive only. This is X and this is Y for us. Perfect. The other line is Y is greater than equal to 2X. So that could be a line which will be starting at 0, somewhere like this, right? So Y greater than means above this line, right? So we'll have something like this. Correct? And the third line, which is 2x plus y less than equal to 60. So if x is 0, y is 60, and if y is 0, x is 30. So this line will be kind of like this, right? So where we expect that when y is 0, x will be 30, and when x is 0, y is going to be 60. Now less than equal to means we'll shade this portion. So as you can see, we get 3 critical points here to analyze. So we'll figure out what are these points. At these points, we'll get the value, like you know here, x value is 6, right? So x value will be 6. We'll find what these values are from the graph, right? We can also calculate. So we'll find these values. And then to get the maximum cost, we are going to multiply the x value with 3. So we'll calculate what is 3x plus 2y equals to. And we look for maximum with respect to these 3 points. So basically we are comparing these 2 points to get our answer. So I hope the concept is clear, right? So let's go to the next page, sketch the graph and try to get our solution. Here's a fresh page and let me write down all the restrictions or the constraints which we worked with. One is x should be greater than or equal to 6. The other one is that y is greater than or equals to 2x. And the third one was that 2x plus y should be less than or equal to 60. That we get from 20 hours of work, correct? So we have to basically draw these 3 lines. So let's begin with the x equals to 6. Okay. Anyway, so let's make a scale here. So we'll say this is 10, 20, 30, 40, 50, 60, right? Because that is the highest number. 10, 20, 30, 40, 50, 60. Okay. So we got x-axis and the y-axis for our variables x and y. Let's begin with this. 2x plus y is less than or equal to 30. It basically means that when y is equal to 0, x will be how much? X will be 30, right? Half of 60. So 10, 20, 30. So that is the value of x. When x is 0, y is going to be 60. 10, 20, 30, 40, 50, 60. So that is 60 for us. And this is 30 for us, correct? Now, since I have very limited space, reading from the graph will not be very accurate. So we'll do some calculations. But on the graph, I'll show you how it should look like. So less than means we are looking into this domain. Less than equal to means line is included, right? So the line is included and that is our first thing. Correct? So we got one equation in place. The other one is y equals to 2x, right? So if I move 10 here, I have to move 20 there, right? So that is how it is, 10, 20. And if I move 20 there, I should move 40. So it's 20 and 20, 40, right? So we get that. So for 10, we get 10, 20, and this thing is 20. Rather, we could say that for 30, it will be 60. This will be better for us. So we'll go up to this place. I think this point is not correct. So we get these points. Origin, of course, 0, 0. So we can join these two. Yeah, this is correct. So we get a line kind of like this. So that is the second curve. And we want to be y to be greater than. So we are looking for a portion which is above this, right? So we are looking for something. So definitely we are looking into this portion which is above it, right? So somewhere here. So we got the second graph. The third one here is y equals to 6, right? So if this is 10 for us, this is 10 for us, 6 will be just more than 5. So we could say that it is a line which is kind of very close to 5. Is it okay? So it seems to be touching 5, but we'll make a point which is slightly less than 5. So this is the line which, let me write this as x equals to 6. When we say greater than, we are looking into this portion. Correct? So we are looking into, so we have a triangle here to work with. Now, to find the maximum earnings in this particular case, we have to analyze these 3 critical points. Now, let's figure out the value. When x is 6, what is y? So let's find. So we have 2x plus y equals to 60. That is the red line, right? This is 2x plus y equals to 60. And then we have x equals to 6. So if I put x as 6, what is y equals to? That gives me y equals to 60, right? 60 minus 2 times 6, which is 12, right? So that gives me 48. So this particular point here will be x is 6 and y is 48. Clear? Now let's look into the other point, which is at y equals to 2x. So we have equation y equals to 2x, right? And if I substitute this in this particular equation, which is 2x plus y, I get 2x plus 2x equals to 60, right? So that gives me 4x equals to 60, and that means x equals to 15. 60 divided by 4. Is that clear? So this particular point here is x is 15 and y value will be twice 15, right? Which is 30. So we have two critical points. Now let us find the earnings for both these points, right? So let's calculate earnings for a point where the x and y value is 6 and 48. So the earnings will be, we know that toy A is for $3 and B is for $2, correct? So that is the cost. So how much is the total earning? 6 times 3 plus 48 times 2. So that gives you 18 plus 96, right? And that gives you 6 and 8, 14, 4, 1 means 114, right? Units I have taken as dollars, not pounds in this case, since my keyboard has only dollars. Okay. So that we get for earnings at this point, we have a dollar value of 3 times 6 plus 2 times 48, and that gives me 114. That is the amount. Let's calculate for the other value, which is 15 and 30, right? So let's do it in a different ink. So for 15 and 30, we have 15 times 3, which is 45, plus 30 times 2, which is 60. So what we get here is 45 plus 60. So 45 plus 60 is 105. So here we get, let me write down here, 15 times 2 plus 30 times, 15 times 3 plus 30 times 2, which is 45 plus 60, which is 105, right? So clearly the higher value is 114. And therefore, in this case, the greatest amount earned will be 114, right, dollars. Is that clear to you? So the idea here is, once you get your inequalities or the constraints, you can sketch the graph. Look into the points of intersection. Each point is to be checked for the maximum or minimum value. In this case, we want the greatest amount. So toy A is being sold for $3, toy B is being sold for $2. So if we sell 6 of A and 48 of B, we earn Hassan earns $114. And the other possibility was 15 of toy A and 30 of toy B. At the rate of 2 and 3, it comes to $105. Since 114 is much higher, that is the greatest amount he could earn in the given scenario. Does make sense to you? So I hope it is absolutely clear. That is how you should be solving questions related to inequalities using graph. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.